Hi everyone, we're going to find the directed distance s in feet during a given time 0 to 3 of object P moving along a coordinate line subject to V equals 3t squared minus 9t plus 6. So basically what we have is our V, and let's factor it so we can find the intersection points between the curve and the x-axis. So when we do that, we're going to get V equals, let's factor out of 3. We get t squared minus 3t plus 2. This equals 3 times t minus 1 times t minus 2. All right, that means t equals 1 and t equals 2 are intersection points. So if we sketch a graph of this, all right, it's a parabola that opens up with the y-intercept of 6, and we're going from 0 to 3. All right, so basically what we want to look at is 1 and 2, and look at this as a sign diagram. So basically, if you substitute in, if you have a little sign diagram, 0, 1, 2, and 3, if you look at a number in between 0 and 1 and substitute it back into this, you're going to get positive. So basically, it's above the x-axis. I know it's supposed to be straighter like that. All right. Between 1 and 2, say 1.5, it's going to be below the x-axis. And from 2 to 3, so if I substitute 2.5 here, substitute in here, it's going to be positive again. So it's going to go up above the x-axis. So something like this. All right. Since that's what we have, we can say that our V is positive here. Our V is negative here. And on from 2 to 3, our V is positive again. Therefore, when we set up our integral, we're going to find the directive distance as s equals the integral from, and this is a s. All right, looks like an integral. S equals the integral from 0 to 3 of absolute value of v of t dt. Now we're going to split it up. Okay, so we're going to go from 0 to 1. So this is going to be, this equals the integral from 0 to 1 of v of t dt. And then we're going to do plus the integral from 1 to 2. And that's going to be negative v of t, because it's negative there, dt. Then we're going to have plus the integral of v of t from 2 to 3. And this one was from 1 to 2, dt. Because from 2 to 3, it's positive. All right, so all we have to do is substitute in our v of t and integrate. So let's do that. We're going to have this equals our directed distance is the integral from 0 to 1 of 3t squared minus 9t plus 6 dt. So used to writing dx, so dt, and then we're going to have minus the integral from 1 to 2 of the same. Everything's always going to be the same here. Then plus dt, plus the integral from 2 to 3 of 3t squared minus 9t plus 6 dt. This is the 3. All right. So now all we have to do is integrate, and that's going to give us t cubed minus 9 halves t squared plus 6t, and this is from 0 to 1, minus, same thing, just keep copying it down. And this one's going to go from 1 to 2, and then plus, copy the same thing down. And this is from 2 to 3. All right, and then we're going to start with 1. And when you substitute in 1, you're going to get 1 minus 9 halves plus 6. Minus, and we don't need to do the 0 because the 0 is just going to 0 that out. Now for this one, we're going to do minus, substitute in the 2. So that's going to be 2 cubed is 8. Minus 2 squared, so this is going to be 18, and then plus 12. Then you're supposed to subtract the 1, but because we have a negative, we can just put plus. And that's going to be the same thing we got here, which is 1 minus 9 halves plus 6. And then we've got to do these last two. So we're going to have this one. This one's going to be, I'm going to move it down here. Plus 3 cubed is 27, minus 81 divided by 2, plus 18. Then we're going to have minus, substitute in the 2, which we already did. We already did the 2 once. So that's going to be minus 8 minus 18 plus 12. Now you can put all this in your calculator or do it mentally, and this will give you 11 divided by 2. And that is your directed distance. Thank you. Have a nice day. Bye-bye.